now we're going to show you also how you can use the similar analogy for designing the spline joint. So as an alternative, we're going to use, of course, the same panel, the same forces, but we'll use the spline. At the beginning, we can try with 200 by 20 millimeters, and we're going to use this time SPAC screws with Supplier's ETA. Here, we're going to add a new calculator and floor-to-floor spline connection. And let's start editing this calculator. So here, again, we're going to type in some of the same inputs. So let's go with Kyle H. Let's select 185 layers. So for spline, we can go with 200 millimeters. We're going to again select continue. So only 1 meter strip is designed. For timber member, we're going to set 20 millimeters spline material, change to plywood, and I'm going to leave the density on 400, but that's specific to material you're using. For screw supplier, let's select specs, and here we can select some of their product families. Also, if you're not familiar with all the products, or you want to check out what are the alternatives at some point, you can notice that you have more information here covering all the information about the screws, covering their geometry, screw family, thread type, head type, diameter, length, service classes, and specification. So you can quickly find out maybe what is something that you can use in your design. So here we can start with Wyrox partially threaded screws. I'm going to select appropriate screw for this design. So let's just scroll down. I'm going to select the washer head, and I'll try with 8 by 80. Let's use SPAC's ETA in this case, and I'll type in 150 as for the beginning. For the appropriate loads, let's type in what we have, so 8 by 86 and 6 by 76 in the perpendicular direction. And for the design Eurocode, so we have gamma, we're going to select long-term, service classes, and no for pre-trailing. So if we go on the dynamic imagery, we can see how this is positioned. So we have spacing, we have a position of the screws. We're going to go to the results and see that the shear capacity in this case is not appropriate. So we have geometry check fulfilled, but we need to either increase spacing or screws. I'm not going to increase the diameter of screw because I think the spacing on this is already at maximum. So let's try to have a less spacing. So if we put to 120, we can have the shear capacity fulfilled here. Also, the difference within the ETAs and the Eurocode here can be seen in the geometry check. So if you use the ETAs from Supplier, you can see that the provisions for and recommendation for the distances between them is something that is more favorable within the ETAs. For the output summary, so as I mentioned, we have geometry check shear capacity. We can go in details and see all the information, and if you want to check what geometry is not appropriate, you have ability for that. And for lateral capacity, again, we have all details, results in this as we have for the previous calculator. So having said that, I can click save, and we can go back to the presentation and to the next calculator.